Good morning, everybody. Today I have to discuss about the class regarding about the faults and their classification. Before going to the class, you have to know about the just fundamentals, how they can the faults, what are the reasons, how they have to happening in the forces acting on the sample, how they can behavior. Everything you have to know that one. So let us start with the diagram. So on the vertical side, they can go about the stress, and the horizontal side you have to go in the strain. So very beginning you have to take about the undeformed sample here. This is the undeformed sample, and we know that initially when you load the sample here, the sample it undergoes to elastic deformation. So in the elastic deformation, on shorten it is a little bit in this direction and extended in this direction when it is applied on the forces on the compressional action. So just because of the elastic and then it is continuous deforming following this dark curve which is elastic curve. Now after this part there are many possibilities. I show you one of the possibility first, that the rock is deforming in a brittle manner. See, and it can either fail in one, that means producing tensional forces, or it can produce more two fracture or shear fracture. See here, the direction of the crack, direction of the force is acting on is side by side. It is called as the shear. It is a mode 2, and the tensional, the force is away from the center. It is mode 1. So here in this curve, something like that reaches the yield stress, and immediately after it produces the failures type of curve, and therefore explain that in this domain we expect a brittle type of deformation. Now in the brittle type of deformation, there is a one is the mode 1. It is happening on the tensional forces. Due to tensional forces it will be happening on this one fractures, and mode 2 is happening on the shear. The force is acting on the side by side, they have to produce in the fracture. The fracture is developing. It is, you have seen, this called as the large scale of fault. Now if the deformation happening on the continuous process, it is happening on the two type of process. One is the it is hardening in the one side and softening in the other side. Now I have discussed about the hardening, that is a continuous process. Now if the deformation continues, for an example, if I have enough pressure and little bit of temperature will be increases, it's a gradually, then we know that it should be show little bit of hardening. It is the hardening, and it is increased pressure and temperature. Then that means deforming the rock we need more stress, and then rock deforms in a homogeneous manner. It is happening on the homogeneous nature, that is happening on the forces acting on the all sides and equal. That's why happening on the homogeneous nature. And the deformation after this yield stress is formed in a deformation. If the strength further continuing, then the rock does not produce any fracture here. Why? Because it is happening on the homogeneous characteristic, that is the forces equal side, there is nothing will be happening on any yielding. Then the homogeneous plastic deformation continues, and it goes in this way, more or more stress requirement. So now we have to see this curve, complete curve. They have to we have seen two possibilities. One is that is the fail in the brittle manner, and second one is the continuous showing of the homogeneous deformation without producing any fracture. And this is the second type of deformation. The brittle one is the first type of deformation. Now we have the another possibility is there. We learned in a deformation mechanism that it can show strain of hardening. This one, strain of hardening. And another possibility, this is a third type is there, that is we can have strain softening. And that happens that we have see the localization here in the sample, and this localization, this shear fracture, see the direction of the action is a side by side is going on, that is a shear fracture, a shear force. uh, that is characteristically different, that we have to see here in the brittle domain happening on the shear action, and show this is a ductile domain, because the rock is accommodating deformation without producing any fracture, and this is the brittle. There is nothing happen, just a fracture will be developed here. There is a continuously happening of the shear fraction. There is a no displacement. We have seen here displacement is going on in the ductile manner. So we have to see the third possibility here. Now that happens here, this position completely deformation sample is a little bit confused, either homogeneous manner or either heterogeneous manner. So already you have to learn about that homogeneous in the equal action of the nature, everything is done homo nature, but heterogeneous the different characteristics will be adopted here. I find the narrow zone where I can generalize all the deformation, and the rest of the body of the rock sample can remain actually undeformed here, or layered formation. Now the same thing happen here. You have to see this one, but here happens here and here it's happen is the brittle nature, it will happen in the ductile manner. So we have to see the deformation is actually under compressional. Already I have to discuss it. Under compressional we can have possibilities of either brittle deformation in mode 1, and in the tensional forces, and another one is the mode 2, it is happening on the shear manner. And we can have possibility of another one is the second one is the homogeneous deformation, and we can have possibility of ductile shear localization or heterogeneous plastic deformation in the, which is also form and deformation. If we continue with this type of deformation, means it is the homogeneous, it is a, then they do not have seen any localization or faulting fractures here in the homogeneous nature. So we will avoid this homogeneous deformation part of time being. We'll most look at this brittle part and ductile part in the context of this lecture of faults and faulting. It will be happening on the two conditions. Faulting will be happening either a brittle manner or ductile manner. You can see the different type of faulting nature, and coming to the coming classes you have to see how they have to happening the forces acting on the given rock strata. The strata there is a happening on the two conditions will be happening on the faulting, either brittle condition or ductile conditions. So what is brittle and what is ductile? You can see the small example here. Seen here the brittle ductile and brittle ductile manner. In the brittle faults or fracture is discontinuity along which the rocks on either side have moved fast each other. They have to move fast each other in a direction parallel to the fracture plane. I have seen here happening on the shear force. There is a rock block will be moving in the past each other. It will be happening on the low pressure and temperature in the future. As seen in the ductile faults are shear zones or ductile shear zones. In the narrow zones of localized but continuous ductile displacement between two blocks without developing any fracture. You have seen here it is continuous process. There is nothing will be displacement will be going on at the scale of observation. It will be happening on the high pressure and temperature, and the brittle faults happening on the low pressure and temperature, and ductile faults happening on the high pressure and temperature. When it will be happening in the both, that is the brittle or ductile, it is called as the brittle ductile. And there is now we have discussed about the fault are defined when two adjacent of rock have moved past each other in response to induced stresses. The stresses means happening on either compressional or tensional or shear. It will be brittle or ductile, and a brittle ductile nature, that is behaving like a rocks in the interior of the geological structures. So it is the normal concept of localized deformation, how the faulting will be happening. Everything is will be generalized in the one graph sheet. I think hope that everyone have to understand the concept of localized deformation, and thank you everybody.